This is where we were in our last video. We had looked at deriving this equation here, which we'll be using later on, from changes in the cylinder. Alright? It applies to other things as well. But here, let's continue looking at the form of this particular equation before we do anything else. This is used in questions that cover the applications of partial differentiation. It's also useful in the partial differentiation of implicit functions. Alright? Now, here we could, for example, consider this particular equation as distance. Say you're looking at distance. Alright? You have a change in distance. We know that distance is equal to speed multiplied by time. Alright? Or if it's speed in a specific direction, it's velocity times time. So this distance is the change in distance, or let's use d for distance, alright, s for speed, t for time. Use lowercase t. So distance is really the change in distance given the change in time times time. Alright? Now the change in distance here is equal to the change in distance time divided by the change in time multiplied by time. So here, distance is speed. This is speed, you know. This here. Change in distance over change in time. Speed is distance over time. If you're going at a certain speed, for example, 50 kilometers per hour. Kilometers per hour means kilometers divided by hour. Change in distance over time, that's speed. And to find your distance, suppose you would drive for 1 hour. You would have covered 50 kilometers. Suppose you drove for 2 hours. You would have covered 50 by 2, which is 100 kilometers, and so on. So speed is distance times time. This is distance. Alright. This is speed. Change in distance times by the change in time. That's like delta V by delta H times time. Alright. And by the way, I shouldn't use this type of delta, you know. I forgot for a moment that here. Alright, this delta is okay, but this one is like partial derivative. So this, I want to use the partial derivative delta here, right? Delta d by delta t, right? Distance is d. I think I'd prefer to use the lowercase d, since everything else is lowercase. So d, distance is changing distance over changing time, time. This is a change in time, small change in time, but we consider as 1 hour that small change. It doesn't really matter for the purpose of this discussion. So here we have a change in, I wrote V, it should be D, right, because I see the V up here, but this is saying a change in velocity, but we're talking about a change in distance. So a change in distance traveled is equal to the speed times a change in the time taken. Alright? So it mirrors what you have here. Change in volume is change in volume by a change in height times, no, change the rate at which volume changes as height changes time a change in height. Now this change in distance is the rate at which the rate of change of distance with time multiplied by the change in time. You see that? Change in volume is the rate of change of volume with height times small change in height. Change in distance equals the rate of change of distance with time times multiplied by a small change in time. Alright? So how does this add to it? Alright, if we consider that we have a journey, 2 parts of the journey, you have 2 legs of the journey. This is leg 1, let's call this time 1. The other one is time 1 and distance 1 is for the first leg of the journey. Then you stop, take a break, and then you continue driving or walking, whatever it is. So change, well, it could be by ear as well. You stop at one airport and then you stop at you go to another airport, right? In driving, it could be that you stop to buy something to eat or stop at a gas station, whatever it is. But here you start the other leg of the journey at a certain average speed. So that's the rate of change of distance 2 with the time that the second leg takes times, the rate of change of distance with time of the second leg of the journey times how long that second leg of the journey takes times 2. Alright? So you see the comparison between them, between this and this. So here now, generally, the equation used is in this form. You have a change in Z, right? Delta Z. You know, alright, my Z as uppercase. In books and on website and so on, you might see it as lowercase z. Change in Z is equal to, so del Z is equal to, and remember you have X and Y changing now. Delta Z, let me cross my Z, delta Z by delta X times del X plus delta Z by delta Y del Y. Right? So this is the general formula used So here you're saying that a small change in z is equal to the derivative of z with respect to x times a small change in x plus the derivative of z with respect to y times a small change in y. Right? It's just like how you have a small, well, in reality it might be considered a large change, but let's consider it small for now. A small change in distance is the speed at which you travel in the first leg of the journey, the time you take, plus the speed at which you travel in the second leg of the journey times the time you take in the second leg. Right? So the general formula is delta z, the change in z, a small change in z, is equal to the derivative, the partial derivative of z with respect to x times a small change in x plus partial derivative of z with respect to y times a small change in y. So that's an important formula which we'll be using in future videos. So I'll see you then.